Welcome everyone to today's session. In today's session, we will try to understand how the atomic size and the metallic character of the elements varies when we move from left to right along a period and when we go down along a group. So we'll start with atomic size. Now when we talk about atomic size, we need to know what is exactly atomic size. So we should know that the atomic size of an atom is indicated by its radius. The atomic radius is the distance between the nucleus of an atom and its outermost shell. So this is similar to that of a circle. Like if you take a smaller circle, it will have a smaller radius, and a bigger circle will have a bigger radius. Now that circle is the orbit of an atom in which the electrons revolve. So what did we say? We told that the size of an atom is indicated by its radius, and also that the atomic radius is the distance between the nucleus of an atom and its outermost shell. This atomic radius is expressed in the unit picometer. If you try to understand picometer, we can figure out that it is even smaller than nanometer. 1 picometer is 10 raised to minus 12. The size of an atom is expressed in picometer. It is the distance between the nucleus of the atom and the outermost shell. Now, as we move along a period, for example, as we move from left to right, we know that the electrons go on increasing. That is, one electron is added to the next element, and that is why atomic number increases by 1, right? So as we go from left to right, an electron goes on increasing in every atom and the atomic number increases. Now try to think about this fact that if electrons are added to the atom, then the total positive charge at the center, that is in the nucleus, should also increase one at a time. Think, if the electrons are increasing one by one when we move from one element to the next element, then the number of protons in the nucleus also should increase in the nucleus. Yes, and that is what exactly happens. As the electrons are added, the positive charge also increases. Here, one very important thing which you should keep in mind is that the electrons are added to the same outermost shell. The electrons are added to the same outermost shell, right? Because the electrons are added to the same outermost shell, the total negative charge in that shell goes on increasing. At the same time, the total positive charge in the nucleus is also increasing. So you see, on one hand the positive charge increases, on the other hand the negative charge increases, and that is why the attractive forces will increase between these two charges. And this increased attractive force is the nuclear pull, that is, the nucleus is pulling the electrons towards itself, and the size of the atom goes on decreasing. Think again, that is, electrons are added to the same shell, right? Now when the electrons are added to the same shell, the negative charge increases. At the same time, the positive charge also increases. And as you go from left to right, the negative charges are increasing as well as the positive charges are also increasing. In such a situation, the nuclear pull also increases. And when the electrons gets pulled towards the center, it's the size of the atom goes on decreasing. So how will you write this answer? So you will start the answer by writing the size of an atom is indicated by its radius. The atomic radius is the distance between the nucleus of an atom and its outermost shell. Then then you have to write, while going from left to right within a period, the atomic number increases one by one, meaning the positive charge on the nucleus also increases one by one at a time. However, the additional electron gets added to the same outermost shell. So, due to the increased nuclear charge, the electrons are pulled towards the nucleus to a greater extent, and thereby the size of the atom decreases. So, try to understand this, that as you go from left to right, in the periodic table, the number of electrons go on increasing. All the electrons are added to the same orbit. So, the negative charge increases, at the same time the positive charge increases, and there is a pull from the nucleus towards the electron. That pull, that is a nuclear pull, goes on increasing, and as you go from left to right, the nuclear pull increases, so the atomic size goes on decreasing. When you look at this in another way, for example, you go down the group, what you will realize is, as you go down the group, the number of shells go on increasing, which we studied already. As we go down the group, the number of shells go on increasing. The first period has 1 shell, second period 2 shells, third period 3 shells, fourth period 4 shells, so on. So now in this case, when we go down the group, also the atomic number increases, but the electrons are added to different shells. Remember this, the electrons are added to different shells. When we go from left to right, the electrons are added to the same shell, but we go from top to bottom. As we go along a period, the atomic size decreases, and as we go down along a group, the atomic size increases. Let me repeat, as we go from left to right along a period, the atomic size decreases, and as we go vertically down the group, the atomic size increases. To sum it up, as we go from left to right, the atomic number increases, the electrons are added to the same shell, the negative charge increases, so the positive charge in the nucleus increases, the nuclear pull increases, and the atomic size decreases. As we go down the group, the number of shells increases, the electrons are added to different shells. When the number of shells increases, the atomic size also increases. Now, understanding the atomic size is very important, because this size will decide the metallic as well as non-metallic character. Now, if you see the periodic table, you know that there are metals on the left. So, let us look at the table, periodic table. Yes, we have here the metals are on the left. Now, the non-metals are on the right. So, as we go from left to right, the metallic property decreases. Now, to understand that, we should understand a fact that metals are electropositive. What does it mean? Metals are those elements who tend to donate electrons and form positive ions. Metals are electropositive. They donate electrons and form positive ions. Now, we know as we go from left to right, the atomic size decreases. So, you can think about this, that if the atomic size is decreasing, it would be very difficult for the elements on the right, okay, so whichever elements are there on the right, all these elements to donate electrons. Whereas if you look at the elements on the left, it is easy for these elements to donate electrons compared to the elements on the right, because on the left the atom is bigger. When the atom is bigger, the nuclear pull on the outermost electron is less, right? Whereas the nuclear pull in the case of these elements on the right is more. So what happens is, it is easy for the elements on the left to donate electrons, whereas it is difficult for the elements on the right to donate electrons. So naturally, if it is easy for the elements to donate electrons, those elements on the left to donate electrons, these elements will behave like metals, and this ease of donating electrons decreases from left to right. Why it decreases from left to right? That is because the atomic size decreases, and when the atomic size decreases, the outermost electrons get pulled by the nucleus, and therefore it is difficult for them to donate electrons. So what we can say? We can say that the metallic property decreases as we move from left to right across a period. So what can you tell about the groups? As we go down the groups, we already studied that the size of the atom increases, right? If the size of the atom is increasing, then obviously it is easy for the atom to donate electrons, because the size increases, the nuclear pull will be less, and with the increase in size and with the decrease in the nuclear pull, it is easy for the elements to donate electrons. Please listen this carefully, that as we go down a group, the atomic size increases. When the atomic size increases, it is easy, okay, for the elements to donate their electrons, right? And if it is easy, then they will behave more strongly as metals. That is why the metallic property increases as we go down the group. So what conclusion we have come? We have come to 4 conclusions. First one, the atomic size decreases when we move from left to right along a period. The atomic size increases as we go down the group. The metallic property decreases when we move from left to right along a period, and the metallic property increases as we go down the group. The metallic property increases as we go down the group. Now, so what conclusion we can come to? We can come to the conclusion that atomic size decreases as we move from left to right along a period. The atomic size increases as we move from top to bottom along a group. The metallic character decreases as we move from left to right along a period, and the metallic character increases as we move from top to down, top to bottom along a group. So the property of metallic character is, we can say, inversely proportional to the atomic size. Atomic size increases, metallic property increases. Atomic size decreases, yes, metallic property also decreases. So in your book they have given this concept in very few lines at the top, and then there is a concept of zigzag line here in the center, okay, and we have seen the zigzag line where we saw that around the zigzag line we have metalloids, right? So metalloids have both metallic as well as non-metallic property, okay. So I hope you understood this topic. So you have to think about this very precisely, because there are 2 questions based on this in the form of give reasons, that is atomic size, why does atomic size decrease from left to right, and second question is atomic size increases along a group as we go down the group, and similarly for metallic property it will be why does the metallic property decrease from left to right, okay. Now one interesting point which I would like to let you know is that in the book they have given some extra information here at the bottom. Let's just go through this paragraph from here. It is understood that atoms have a tendency to form a cation by losing its valence electrons. That is what I told you, metals are electropositive. This property is called electropositivity of an element. On the other hand, an atom of a non-metal has a tendency to form an anion by accepting electrons from outside into its valence shell. So that is, metals will donate electrons and non-metals will accept electrons. Okay. Now then what we should know is all the electrons in an atom are held by the attractive force exerted on them by the positively charged nucleus. Right? That is, the electrons are held by the nucleus, and the electrons in the inner shells lie between the valence shell and the nucleus. Because of their presence, the effective nuclear charge exerting on the attractive force on the valence electron is somewhat less than the actual nuclear charge. Yes, this is one interesting point which has been mentioned here. Because of the electrons in the center, in between, not in the center, sorry, in between the outermost valence shell and the center, because of the presence of the electrons between the outermost valence shell and the nucleus, the effect of the negative charge, effect of the nuclear pull, the effect of the nuclear pull on the outermost electrons is somewhat reduced, right? And if you look, the number of valence electrons in the metal is considerably small, right? And so the effective attractive force acting on the valence electrons is also small. Why it is less is because the middle electrons which are there, they are shielding the outermost valence electrons from the nuclear pull. Okay, but as you know that as we go from left to right, this nuclear pull increases, right? Because of the increase in the nuclear pull, the atoms will not have an ability to donate electrons, so the tendency will be less. Okay, so that is why, as a combined effect of these two factors, metals have a tendency to lose valence electrons to form cations having a stable noble gas configuration. This tendency of the element is called electropositivity. So they have tried to explain even the point that the effective nuclear charge on the outermost valence electrons is small, but you should remember that yes, it is this effective nuclear charge which is responsible for making the atom small. And as we go from left to right, obviously when the electrons are added to the outermost shell, the nuclear charge will go on increasing and the atomic size will go on decreasing. So this is a very critical topic, is asked every year almost in the board exam. I hope you are thorough with this. In case you have any doubts regarding this, please do watch the video again, and still if you have any issues, you can freely email me at support@ramnathshetty.com. Thank you.